All right, welcome back. So in a separate video, I introduced the idea of what a trig function is. This video is just specifically for practicing some problems using those trig functions. Okay, so two things to review before we start using trig functions is it's really important you establish what angle you're talking about, because in reference to this angle, you will use different trig functions, right? Like the sine and the cosine are different depending on which angle you choose. So we use the term reference angle often to say in reference to this angle, we would name this side always the hypotenuse, even if you had chosen this other angle on the other side. But in reference to this angle, the two legs will be named differently. The leg across from the angle is called the opposite leg, and the leg next to the angle is called the adjacent leg. Okay, so in reference to this angle, that's what we're going to call those sides. And the second thing is Sohcahtoa, which we can often write as Sohcahtoa. I like writing it like that because then it already shows kind of the fractions that you'll get. That means that the sine is equal to the ratio of the opposite over hypotenuse. So in that picture up there, the sine of this angle is the ratio of these two sides. Okay, the cosine of adjacent over hypotenuse, or cosine is the adjacent over hypotenuse. So the ratio of these two sides is the cosine. And then finally, the tangent is equal to the opposite over adjacent. So the tangent is the name of the ratio of the two legs in a right triangle. This is the tan. So in reference to this angle, we would name this ratio the cosine, this ratio the sine, and this one the tangent. So that way we could clearly communicate with our calculator and say in reference to a 20-degree angle, what are the ratio of these two sides of the triangle? And our calculator will say, oh, that's 0.578 or whatever. Okay, choose the angle so you know which sides you're talking about, then choose the right trig function. So let's actually use it. Oh, yeah, before we use our calculators, we're going to do everything in degrees. So just go ahead and make sure that the sine of 90 degrees is equal to 1 in your calculator. Degrees can be measured in a variety of different ways, mainly in either degrees or radians. If you type in the sine of 90 and you get something like 0.89 ... then your calculator is just set to the different type of angle measure. And you could just quickly Google a video on how to, and just type in your model number. How do I change this model number from radians to degrees? And either a video or a little, instruction tutorial will tell you how to do that. So the sine of 90 should be 1. Okay, so let's go down here and actually use this, okay? So first things first, in reference to this angle, okay, I'm going to find x, so I'm going to label my sides. In reference to 41 degrees, this is my hypotenuse, always. This one is the opposite. This one is the adjacent. And so out of my Sohcahtoa, I have my opposite over adjacent. I know nothing about the hypotenuse. So I am going to say the tangent of my angle is equal to the ratio of the opposite. Ooh, I almost made a mistake there. The opposite side, which is 12, over the adjacent side, x. Okay, so now I'm going to solve this. Now, how do you solve this? Okay, now the tangent of 41, this is just a single number, right? I can plug this into my calculator, and that's just like a number. So this is analogous to, I'm making this number up, but this is analogous to solving the problem 5 equals 12 over x. Okay, now the tangent of 41 is probably not equal to exactly 5, but this is an analogous situation. If I want to solve this, I would multiply by x, because that's within the denominator. I would say, okay, those cancel. So now I've got 5x equals 12. And then I'm going to say, oh, well, that's just a number times x, so I'll divide by 5 on both sides. And I get x equals 12 over 5. If you're more comfortable in that first step saying, I actually like putting the 5 over 1 and cross multiplying, you still get 5x equals 1 times 12, so you get the same result. That's totally okay. So over here, I'm going to say, all right, to solve this original problem with tangent of 41 equals 12 over x, I'm going to multiply both sides by the denominator, and that gets rid of my fraction. And now I've got x times the tangent of 41 degrees equals 12. And again, this tangent of 41, this is a single number. This is just like when I had 5x equals 12. If you have 5 times x and you want to get rid of that number to get x by itself, you just divide by that number. So I'm going to go divided by tan 41. It's just a single number. I could plug it into my calculator anytime. I just prefer to do it at the end of the problem. So we get these cancel and we get x equals 12 divided by the tangent of 41 degrees. Okay, so now I'm going to go to my calculator and plug that in. Whoops, wrong way. Okay, tangent, or 12 divided by tangent of 41. So 12 divided by the tangent of 41 degrees is 13.804. So I got x is around 13.804, and it says round it to the nearest tenth. So I get x is around 13.8. Okay, let's just start speeding that up and doing a couple more problems. So I'm only given one angle here, although I could easily, with subtraction, 180 minus 90, 58, I could find that this other angle is 32 degrees. Then I might want to do that. In this case, I won't, okay? So I'm going to use the angle they gave me. I'm going to say I've got my opposite. I want to find my adjacent. I don't know anything about the hypotenuse. So I am again going to use my tangent. So the tangent of 58 degrees is equal to the opposite side over my adjacent. I'm going to solve it the same way. I'm going to multiply by x on both sides. I'm going to get x times the tangent of 58 equals 22. Now I'm going to divide by that number. So I'm going to divide by tangent of 58, which is just a number. And so I get that x equals, and then 22 divided by the tan of 58. Okay, so that missing side, 13.747. So x is around, again, to the nearest tenth, so 13.7. Okay, so now we're going to start using something other than tangent. Let's see how this works out. So find the value of x here. Let's go with purple. So with respect to this angle, I've got my opposite side. I've got my hypotenuse. I do not have the adjacent side. So referring to my Sohcahtoa, if I've got opposite and hypotenuse, opposite over hypotenuse, I'm dealing with my sine. So I go down here and I say the sine of 42 degrees is equal to 2 over x. We're going to do that same solving, times by x. We get x times the sine of 42 is equal to 2. I'm going to just start using the same color here. Sine of 42 divided by sine of 42. And we get x equals 2 over the sine of 42. Okay, again, we're going to go over here. And that is 2.988. So x is approximately 3.0, because if I stop here, I have to round that 9 up. That brings me to 3.0. Okay, so let's skip over to number 21 here. I'm doing that because we'll use a different function. Let's go blue here. In respect to my angle, I have the adjacent and the hypotenuse, and I have nothing to do with the opposite side. So my A and H, that's my ka. So cosine of the angle is equal to adjacent over hypotenuse. Now this one ends up being easier as well, because if I multiply by the denominator on both sides by that 26, I'm done solving. I already have x by itself. So x is just equal to 26 times the cosine of 39 degrees. So I go over my calculator. It goes to 20.205. Okay. Again, chopping that off, I get x is approximately 20.2. Okay. Now, some of these problems here will ask you to solve a right triangle. I'll mention this again in the future. But when it says solve a right triangle, what this means is find every side length and every angle measure. Okay, so let's go down and do two of these problems together. Okay, so here's a problem that I'm given. Well, I already know this angle's 40 degrees. I already know this angle's 90 degrees, but I don't know the measure of angle K, so that's something I'm missing. I know that the hypotenuse is 8, but I don't know this side, and I don't know this side. So to solve this right triangle, I need to find three things. Okay, well, the measure of angle K is the easiest. That's just 180 degrees minus 90 minus the 40. And so we get that the measure of angle K is equal to 50. That didn't take anything advanced, okay? Now looking at this, I know I can't use the Pythagorean theorem because I've only got one side length, so I got to use some trig. Once I get that first side length, though, I could use Pythagorean theorem. So let's go ahead and do that. Okay, so in reference to my 40-degree angle, this is the opposite, this is the adjacent, and this is the hypotenuse. Okay, so let's, kind of arbitrarily, whether we solve for the opposite or the hypotenuse, let's solve for the opposite first. So the sine, that's opposite over hypotenuse. So the sine of 40 degrees is the opposite, that's side KL, over the hypotenuse, which is 8. And I want to solve for that KL. I want to find that length. So I can multiply by 8 on both sides, and that's it. That's my side length. So I know that KL is just equal to whatever 8 times the sine of 40 is. Similarly, off to the side, I could have said, okay, well, the cosine of that same angle is equal to the adjacent over hypotenuse. So that's equal to the side length of ML. If you're more comfortable calling this like a letter X and having an X here instead of ML, that's totally okay. I'm just going to use 2 letters. That doesn't confuse me as a name, but you can absolutely just use a single letter. Okay, over 8. And again, I'm going to say, okay, well, I can multiply by 8 on both sides, and that cancels. And so I get that my length of ML is exactly 8 times the cosine of 40. So now, since up here it says round the decimal answers to the nearest tenth, I need to get an approximation for each of those, okay? So, let's say 8 times the sine of 40 degrees first. Oh, minus, no, 8. Let's just do sine of 40 without a multiplication sign there. So that's 5.142. So around 5.1, I'll leave off the 4.2, taking care because the 4 was the next thing, so I don't need to round up. And then 8 cosine 40. Okay, and that's equal to 6.12. Again, I'm going to just write 6.1. I'm not rounding up because of that 2. All right, so now I'm going to do the same thing over here with number 12. Again, with number 12, what am I missing? Okay, well, I don't have this side length. I do have 15 on the bottom. I don't have the hypotenuse. And I don't have angle t, but I do have a right angle and 90 degrees. Okay, so with respect to my 57 degrees, I could first name all the sides. This is opposite, this is adjacent, this is hypotenuse. Okay, and I know I have to use some trig because I don't have two sides to find that third using the Pythagorean theorem. Okay, first, just to get it out of the way, we could say, well, the measure of angle t, we just take the 180, subtract the 90, and subtract the 57, and we get that the measure of angle t, just using some simple subtraction, is 33 degrees. Okay, now we got to use trig for the others. Okay, so first, let's find that adjacent side. So if I'm talking about the opposite that I have and the adjacent that I don't have, I'm going to say, okay, well, the tangent of 57 degrees is equal to 15 over x. And now, you know what? If I got to multiply by x here, and I got to divide by tangent, I just want to show you an alternative to this. That's totally correct, but the algebra is slightly more difficult. Since I already know that t is 33 degrees, I could just say, you know what? I'm going to instead look at the tangent of 33 degrees. So up here, what I'm going to do is I'm going to erase the fact that this was adjacent, and that hid or unhid something I had covered up there. So with respect to the 33 degrees here, this side is now my opposite, and this side is now my adjacent. And look what this does. Going back to green here, now the tangent of 33 degrees would be the opposite side, which is RS, or my unknown, if you would call it X, that's okay, over 15. And that makes the algebra a little bit easier, because now, if I just multiply by 15, I'm done. Now, for some people, that's not worth it. For some people, that's a cool trick that you might use. I just wanted to show it to you. So we get that the length of RS is equal to 15 times the tangent of 33. So I'm going to go ahead and find that right now. That's RS is approximately. Now, since the problem isn't done, and I'm going to reuse this number, I'm not going to round it right now. I'm going to keep extra decimal places. Since I'm going to the nearest tenth, I'm going to keep 2 extra or 3 extra decimal places. Let's say I'm going to use 3 decimal places. Okay, so 15 tan 33. Okay, so that gives me 9.741. Okay, 9.741. Now I'm not going to box that in because I will need to shorten that to the nearest tenth. But first, I'm going to use that now to do the Pythagorean theorem on this. I know that that number, one of the legs squared, plus the other leg squared, is equal to that hypotenuse squared, so RT squared. Okay, so then my RT is just equal to, if I square root both sides, is just equal to the square root of that whole other side. So 9.741 squared plus 15 squared. I don't need to use more trig, although absolutely you're welcome to. But once you have 2 legs of the right triangle, you can always use the Pythagorean theorem. So, okay, so back to our calculator. I had some glitches there, so I had to cut out. So I just put that into my calculator. I get out 17.885. So RT is equal to 17.885. Oh, that's an approximation. So now that I'm done, I could approximate both of those. So RS is approximately 9.7. If I would have rounded that at the beginning of the problem, I wouldn't have gotten 17.885. So actually, let's go back to the calculator and see if we would have gotten the same result. Okay, so would we have gotten 17.9? So I'm going to use just 9.7 as though I had rounded early in this problem. Let's see how close it is to 17.885. Okay. So square root of 9.7 squared plus 15 squared. That's 9.7. 17.863. So we'd still get 17.9, but you can tell that these digits over here, the last, second, and third, are different. Okay, so I just want to make a final comment, but that's all the practice problems. If we go down here, and it says solve this right triangle, well, okay. Looking at it, I'd say, okay, well, I mean, I could find this missing side for sure. I mean, I could just go 3 squared plus b squared equals 9 squared. Or actually, you know what? I'm just going to go ahead and divide this by a scale factor of 3. And I'm going to look at this as a 3, 1 b problem here. And so I'm going to go 1 squared plus, and this is a different b, so maybe I should have used a different letter. But b squared equals 3 squared. That's 1 plus b squared is 9. B squared is 8. B equals square root of 8. Then I can multiply it by 3, and I get that this is 3 root 8 here. Now that could be simplified further, since this is root 4 root 2, or 2 root 2. So then when I multiply by 3, I get 3 root 8, which is the same as 6 root 2. Okay, so I could find that missing side. I could have used a calculator and got a decimal. But the problem is how do I find this angle? And this angle. Now I know by side, 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 every single triangle with those sides is, I mean, they're the same, exactly the same, either rotated or flipped around, but there's only one unique triangle made with those 3 side lengths. And by SSS, it's congruent to every other triangle with those 3 side lengths. So can I just take a protractor to that thing and measure the angle? Shouldn't there be a way to finding it? And that's what the next video will be. And the next video is all about inverse trig functions. And what an inverse trig function does is it undoes a trig function. In other words, a trig function, a normal one, you plug in an angle and it brings you the ratio of sides. Right? That's what a normal trig function does. An inverse trig function takes in the ratio of the sides. So you know the ratio of the sides in number 14, and it gives you what angle generates that ratio. So it can find the angle of this triangle. It can find the angle over here. So it can find both of those acute things. It takes you backwards. Once you know that ratio, you could say, well, can't I just ask my calculator what angle gives me that ratio? And yeah, you can. That's what an inverse trig function is. And that'll be our next video. So hope you enjoyed this video. Good luck.